Welcome to clickmyproject.com. The project title is Automatic Artifact Rejection from Multichannel Scale-up EEG by Wavelet ICA. The project abstract is a novel technique of Automatic Wavelet Independent Component Analysis, that is AWICA, for automatic EEG artifact removal is presented. Through AWICA, we claim to improve the performance and fully automate the process of artifact removal from scale-up EEG. AWICA is based on the joint use of wavelet transform and of ICA. It consists of two-step procedure relying on the concepts of kurtosis and Reynolds entropy. EEG data are proceeds by AWICA and the results achieved were compared to ones obtained by applying to the same data the wavelet enhanced ICA method recently proposed by other authors. The project flow diagram is to remove the noise from our EEG signal by using an wavelet transform. Initially we have to collect the dataset. In this dataset are EEG signal. Next we have to choose any one of the signal. It is our input of EEG signal. Next we have to remove the noise from signal by using on Butterworth. Next we have to apply the DWT. In DWT means discrete wavelet transform. Next we have to remove the noise and extract the features about the signal. Here we are using the WICA and AWICA. That means independent component analysis. Then we have to classify the signal. Finally we have to measure the performance of the corresponding signal. Our project source code file was run from the command window. In current folder shows our main code files. So we are going to run the main.m. So it is our main code file. So you have to run the main.m. After run our program, so the coding will be going to dataset. So it is 4 different datasets are there. So it is our DAT file. So we have to choose any one of the datasets. So it is our process. So initially we take as a input signal as a EEG signal, and next we have to apply the wavelet D coefficient and wavelet D approximate coefficients. So it going to analyze the coefficient values of our input EEG signal. So next we have to apply the DWT D coefficient and DWT approximate D coefficient. In DWT means discrete wavelet transform. It's going to analyze the noise and predict the noise to remove the our inverse DWT ICA. So next we have to find the noisy signal from our wavelet transform. So it is going to predict our input signal as a blue color line and external noise as a red and green color line. So it's going to a square wave or short tooth wave, like it is going to mingle with our input signal. So we have to extract the noisy of our signal. So we are going to apply the ICA transform. In ICA means in independent component analysis. So next we have to find the ICA signal. So it is going to convert the our input signal as a square. So another signals are sine or sawtooth wave. So it is going to predict our input signal. So we have to apply the inverse ICA of our process. So in our inverse ICA, it's going to get our input signal like as a sawtooth waveform. So others are sine wave or sawtooth wave. So we have to extract those signal to remove the noise and extract our input signal as a noisy signal. So remove the noise from our input signal. So we have to extract the signal. So finally we go to apply the inverse DWT, that means inverse discrete wavelet transform of our signal. So finally we get our input signal. after removing our noise. So we have to compare those signal. So it is our input signal, so it is after applying our inverse discrete wavelet transform of our signal. So according to that signal, so how many percentage of accuracy we will get? So approximately we have to get the 90% of accuracy of our input signal. So we have to run the another signal for our, we have to check another signal also. So it is shown on the EEG denoise signals. So it is also going to like that process. So it is also get the noisy signal, and we have to apply the ICA of our noisy signal. Then we have to get the inverse ICA of our input signal, and we have to extract and apply the inverse ICA of our input signal. Finally we got the accuracy value. So the project demo was completed. Thanks to watching this video.